Today we will be dealing with nodal analysis of network theory. We shall begin with a problem, and before that let me explain to you what nodal analysis is. Nodal analysis is based on Kirchhoff's current law, which states that the algebraic sum of the currents meeting at a point is 0. Every junction where two or more branches meet is regarded as a node. See, you can see the currents may be flowing into the junction or away from the junction. We can consider this as I1, I2, I3, and this is node A. Therefore, the current at the junction can be considered with an equation, that is, the current into the node we should take it as negative, and current moving away from the node should be taken as positive. So we can write the equation KCL for node A as I1 minus I2 plus I3 is equal to 0. This is the basics you should know for KCL, for applying KCL for your problems. So now we will begin with a problem. Calculate the current through 2 ohm resistor for the network shown in the figure. So now we are going to write the node equations for this circuit. So we have to find the current through 2 ohm. We have to find the current through the 2 ohm resistor. This is the 2 ohm. So by nodal analysis we have to find the current. So we have to write the node equations, and we can see there are two nodes VA and VB. So I am going to write the node equations for node VA and VB. So by applying KCL at node A, KCL at node A, we can write, I have told you, the current entering into the junction is taken as negative and current moving out of the junction is taken as negative. So here we have, if the direction of the current is not given, we can take it as the current is moving out of the junction. Here at node A we have 3 branches, so we are considering 3 currents in these directions. So 3 currents, 1, 2 and 3. So we can write the currents using the voltages. First we can write this current VA minus 20 by 1. That is the current flowing in this branch. And now we can see the current in this branch that is also flowing away from the junction. So we can write it as positive. VA minus 0, that is ground. So VA by 1 plus. Now the current in this branch, VA minus VB by 0.5 is equal to 0. That is, the current at the junction is equal to sum of the currents at a junction is equal to 0. So on rearranging, we will get it as 4 VA minus 2 VB is equal to 20, and that is equation number 1. Now we can write KCL at node B. Okay. Now we can consider the node B. So there are 3 branches of node B also. We can consider the current flowing away from the junction at node B. So we can write the KCL at node B. That is, we can first write this current. We can write it as VB minus VA by 0.5. It's 0.5 plus, next we can write this current, that is VB by 2 plus, next we can write this current, that is VB minus 20 divided by 1 is equal to 0. And now we can rearrange this as minus 2 VA plus 3.5 VB is equal to 20. So now we have got two equations, equation number 1 and equation number 2, and from this there are 2 equations and 2 unknowns. So you can use a calculator to find what is VA and VB. And using a calculator we will get a VA as 11 volt and VB as 12 volt. So the question is, what is the current through 2 ohm resistor? So the current through 2 ohm resistor, current is equal to V by R, where the current is VB by the resistance is 2. VB we know that it is 12 and 12 by 2 is equal to 6 ampere. This is how we use nodal analysis to find the current through 2 ohm resistor.